Let's look at some ocean continent convergent boundaries. So in a convergent boundary, the two sides converge or move together. So here along the west coast of South America is a very good convergent boundary. And you can see that at 79 millimeters per year, the Nazca plate here is converging with the South American plate on this side. And that's forming a subduction zone along here where the Nazca plate is sinking back into the earth and being recycled inside the earth. So along a subduction zone or a ocean continent boundary, you're going to have several things that are going to form. One of them is a deep trench. So you've got the abyssal plain, the flat ocean floor here, and then you've got a very deep trench. In this case, it's called the Peru-Chile Trench. And also, you have then right up against the edge of the continent, kind of a bunch of material that was either scraped off the plate that's going down or shed off the continent over here. We call that an accretionary prism or an accretionary wedge. So it's a bunch of stuff that's kind of right along the coast here. And then you have the shoreline, and then you have a chain of mountains here. In this case, these are the Andes Mountains. And then in the back, there's usually a lower area, a back arc basin that is formed behind the mountain range. So those are some of the landforms that we can see there. And along with that, you'll notice that there are lots of volcanoes. So these are all volcanoes up the coast here. Big chain of volcanoes, and these are very dangerous, explosive types of volcanoes. And the reason why we have volcanoes here is due to the melting that happens due to water being expelled from this plate as it subducts underneath South America. So as this plate subducts under South America, it has been under the ocean for a long time. It tends to lose some of its water into the mantle. This has the effect of lowering the melting point of the mantle materials and causing them to melt. And then that melt eventually rises up because it is less dense than the surrounding rock and erupts at the surface and forms this chain of volcanoes here. And that's part of the Andes volcanic chain. Now, we also have a lot of earthquakes. So if we switch to this view here, the IRIS earthquake browser, we can see here's the boundary right here. And in this case, almost all of the earthquakes are on one side of the boundary and not the other. And they're on the side of the overriding plate. So this is South America, and that one is staying up at the surface. And there's the Nazca plate here, which is subducting underneath South America. And so all of the earthquakes, for the most part, are on that side of the boundary. Very few on the oceanic side over here. So there's a lot of earthquakes, and they range from being shallow to deep. So you can see that right near the boundary, they are quite shallow, less than 33 kilometers, and they get deeper and deeper as you go away from the boundary. And over here, they are almost 800 kilometers deep, so very, very deep on this side. We can view that in 3D here. So, and see how you can see these earthquakes as the subduction happens, that they are in a wedge shape that is kind of showing that sheet of lithosphere going down inside the Earth. So back to the earthquake browser here, and we can also say that these are very big quakes that can occur along there. If we go to the other formats here, we can see they range, in this case, up to about an 8.4 magnitude. And in fact, they can go a lot bigger. So it was along this boundary where in 1960, the biggest earthquake ever recorded happened. It was over probably about a 9.5 earthquake that occurred off of Chile back in 1960, and that was a really big quake. So the biggest earthquakes, magnitude 9 plus earthquakes, happen along this type of boundary. Other than that, as far as the seafloor age goes, back to Earth, And we can turn on the seafloor age there. And what you can see is that there's really no correlation at all. There's a lot of different ages along here. So in some cases, the seafloor has been there a long time and is subducting. Other cases, it may have formed recently and be subducting there. So there's really no correlation with this type of boundary and the age of the seafloor. And those are the characteristics of the ocean-continent convergent boundary.